Our story begins way back in 1977, a time before most of us were even born. NASA launched a brave little explorer named Voyager 1. Its mission was simple yet incredibly ambitious, to visit the giant planets Jupiter and Saturn, and then keep going, flying farther from home than any object ever made by human hands. For decades, it has sailed silently through the vast, cold emptiness of space, a tiny testament to our boundless curiosity. It's like we tossed a message in a bottle into the great cosmic ocean, hoping to learn what lies beyond our familiar shores. Voyager 1 represents the best of us, our desire to explore, to question, and to reach for the stars. Imagine traveling for over 45 years without ever stopping. That is the incredible journey of Voyager 1. After giving us breathtaking close-up pictures of Jupiter's swirling storms and Saturn's magnificent rings, its primary mission was complete, but its adventure was far from over. The spacecraft continued its voyage, heading towards the unknown boundary where our solar system ends and the vast expanse of interstellar space begins. It has now traveled over 14.9 billion miles from Earth, a distance so immense that it's hard for our minds to even grasp. It is a lonely sentinel in the dark, still faithfully reporting back what it finds. The spacecraft itself is an engineering marvel. It doesn't have big solar panels like many modern satellites because the sun is just too far away to provide power. Instead, it gets its energy from a special power source that uses the heat from decaying plutonium. This has allowed it to keep its scientific instruments and its radio working for decades longer than anyone originally planned. Despite its aging technology and dwindling power, Voyager 1 continues to be our eyes and ears in the cosmos, a true pioneer venturing into territory that humanity has only ever dreamed of reaching, sending back postcards from the edge of forever. As of today, September 30th, 2025, Voyager 1 is so far away that its radio signals, traveling at the speed of light, take more than 21 hours to reach us here on Earth. Think about that for a moment. When NASA scientists send a command, they have to wait nearly 2 full days to receive a confirmation that the spacecraft got the message. This incredible time delay highlights the sheer scale of our solar system and the immense distances involved in deep space exploration. It's a slow and patient conversation with the void, a dialogue that continues to rewrite our understanding of the universe and our place within its grand unfolding story. Just recently, Voyager 1 sent back some truly astonishing news. As it crossed the final frontier of our solar system, a boundary called the heliopause, it encountered something scientists have nicknamed a wall of fire. Its instruments measured temperatures reaching an incredible 54,000 degrees Fahrenheit, which is much hotter than the surface of our sun. This might sound terrifying, like something out of a science fiction movie, but it's not a fire in the way we think of one. There are no flames or burning embers. Instead, it's a region of superheated gas or plasma, marking the edge of our sun's influence. So what is causing this incredible heat? The fire is created by a cosmic collision. Our sun is constantly blowing a stream of charged particles, called the solar wind, out in all directions. This solar wind travels billions of miles until it crashes into the particles of interstellar space, the stuff that exists between the stars. At this boundary, the particles are slammed together and accelerated to nearly the speed of light. This immense speed and energy is what Voyager's instruments are reading as extreme temperature. It's a natural, invisible barrier created by the physics of our own star interacting with the galaxy around it. You might be wondering how a little spacecraft could possibly survive flying through something so hot. The secret lies in the emptiness of space. Although the individual particles in this region are incredibly hot and moving super fast, they are also incredibly far apart from one another. The gas there is what we would call a near vacuum. It is extremely thin and sparse. Because of this, very few of these high-energy particles actually hit the spacecraft. It's like being in a huge, empty room with just a few super-fast ping-pong balls bouncing around. The chances of getting hit are very low, so Voyager 1 passed right through without being melted. This wall of fire at the heliopause is more than just a scientific curiosity. It's our solar system's protective shield. This boundary, also known as the heliosphere, acts like a giant magnetic bubble that wraps around all the planets, including our own. It deflects a significant amount of dangerous, high-energy cosmic rays and interstellar radiation coming from deep space. Without this protective bubble, life on Earth might not even be possible. Understanding how this shield works is incredibly important. especially as we plan for future missions that will one day carry humans into the cosmos beyond our home. One of the most exciting parts of science is when you find something you didn't expect, and Voyager 1 has delivered a fantastic puzzle for us to solve. For years, scientists had models and theories about what the magnetic field would be like at the edge of the solar system. They predicted that the sun's magnetic field, carried outward by the solar wind, would be very different from the magnetic field of interstellar space. They expected to see a clear and distinct change as the probe crossed from one region into the other. It seemed like a logical and straightforward assumption based on everything we knew. But that's not what Voyager 1 found at all. To everyone's surprise, the data showed that the magnetic fields on both sides of the heliopause were remarkably similar. It was as if the sun's magnetic influence was somehow leaking out and connecting with the galaxy beyond. This discovery sent scientists scrambling back to their drawing boards. It challenges our fundamental understanding of how stars interact with their galactic environments. It's a perfect example of why we send probes to explore, to test our ideas against reality, and discover the things we never even thought to ask about. The leading new theory to explain this magnetic mystery is a process called magnetic reconnection. Scientists now believe that the sun's magnetic field lines are stretched out by the solar wind, like cosmic rubber bands, all the way to the heliopause. There, instead of just stopping, they break and then reconnect with the magnetic field lines of interstellar space. When these lines snap together, it releases a tremendous amount of energy. This energy release is what scientists now think is helping to heat up the plasma in the wall of fire, contributing to those extreme temperatures that Voyager 1 measured. This puzzle is more than just an academic exercise. Understanding the behavior of magnetic fields at this scale helps us learn about plasma physics in a way we could never replicate in a lab on Earth. The heliopause is a gigantic natural laboratory where we can observe fundamental forces of the universe at work. The data Voyager 1 is collecting about these magnetic fields and the superheated plasma helps us refine our models of our own cosmic neighborhood. Each new piece of information helps us build a more complete and accurate picture of the bubble we live in and how it protects us. Voyager 1's continued mission is a stunning display of human ingenuity and resilience. Let's remember that this spacecraft was built with 1970s technology. Its computers have less memory than the key fob for your car, yet they have guided it across the entire solar system and continue to operate flawlessly in the harsh environment of interstellar space. The probe runs on just a few watts of power for each instrument, less than what it takes to power a refrigerator light bulb. NASA engineers have had to become incredibly creative to keep it alive, even recently reviving thrusters that hadn't been used in over 2 decades to ensure it could keep its antenna pointed toward home. Every piece of data Voyager sends back is precious. Those faint signals are captured by enormous 230-foot radio antennas on Earth, part of the Deep Space Network. These giant dishes are our lifeline to our most distant explorer, straining to hear its whispers from across the void. The fact that we can maintain this connection at all is a triumph of engineering. This mission continually pushes the boundaries of what is possible, not just in terms of distance, but in our ability to manage a complex machine from billions of miles away, keeping it healthy and productive for nearly half a century. The discoveries from Voyager 1, like the wall of fire and the magnetic field puzzle, are fundamentally important. They help us understand our place in the universe. By studying the boundary of our own solar system, we learn about how all star systems might work. This knowledge is crucial for the future of space exploration and our search for life elsewhere in the cosmos. It informs us about the kind of environments that might exist around other stars and what it takes for a planet to be habitable. Voyager is not just exploring space, it's providing context for our own existence. Ultimately, Voyager 1's enduring journey is a source of profound inspiration. It is a symbol of humanity's unyielding drive to explore and to know what lies over the next hill, or in this case, beyond the next planet. It carries with it a golden record, a collection of sounds and images from Earth, a greeting to any civilization that might one day find it. While its power will eventually fade, likely sometime around 2030, its voyage will not end. It will continue to drift through the Milky Way for millions of years, a silent ambassador from a curious world, and a timeless monument to our desire to reach for the stars.